Hello, I'm Dr. X. Today, we're looking at a sobering new study from the Texas A&M College of Veterinary Medicine and Biomedical Sciences, published recently and already generating discussion. The researchers found that regularly taking very high doses of certain common antioxidants can have unexpected and potentially harmful biological effects. Specifically, in their animal model, excessive antioxidant intake altered sperm DNA integrity and appeared to influence craniofacial development in the next generation. The headline takeaway is simple but important: more antioxidants are not always better. While these compounds protect cells from oxidative damage in moderate amounts, flooding the system with extremely high supplemental doses can disrupt normal biology, sometimes in ways that affect fertility and even the development of offspring. Over the next 10 minutes, we'll unpack this step by step, first with straightforward logic and everyday examples, then through the physiological and behavioral realities, and finally with the scientific details and what it means for you. Let's start simple, with everyday logic and relatable examples. Imagine antioxidants as firefighters in your body. They put out small oxidative fires, free radicals, that can damage cells every day. A few well-placed firefighters are great, they keep things under control without causing chaos. But what happens if you suddenly send in hundreds of firefighters for every tiny spark? They start bumping into each other, spraying water everywhere, putting out necessary signals, and even damaging the very structures they're meant to protect, like the delicate wiring, DNA, in sperm cells. That's essentially what this Texas A&M study suggests with high-dose antioxidants. The researchers gave male mice megadoses of common antioxidants, far above what you'd get from food, and found changes in sperm DNA that carried over to affect how the pups' faces developed. It wasn't dramatic birth defects, but measurable shifts in craniofacial shape. Logically, this makes sense: biology thrives on balance. Too little protection lets damage accumulate. Too much interference can throw off finely tuned processes like sperm maturation and early embryonic signaling. Real-world example: many people load up on high-dose vitamin C, vitamin E, coenzyme Q10, or resveratrol supplements thinking more protection equals better health. But if those doses are excessive and chronic, they may blunt the body's own adaptive responses or alter epigenetic marks passed through sperm, potentially influencing traits in children. The study reminds us: food sources, berries, nuts, greens, dark chocolate, deliver balanced, moderate amounts with built-in checks. Supplements, especially megadoses, can tip the scale too far. Now, let's deepen this with physiology and behavior. Physiologically, antioxidants neutralize reactive oxygen species, ROS, unstable molecules that can harm DNA, proteins, and lipids. At normal levels, ROS also serve as important signaling molecules. They help sperm swim properly, trigger egg activation after fertilization, and guide embryonic development. Flood the system with high-dose antioxidants, and you can suppress these necessary ROS signals. In the Texas A&M model, excessive antioxidants appeared to cause oxidative stress. Paradoxically, by disrupting redox balance, led to sperm DNA fragmentation or abnormal methylation patterns, and altered craniofacial morphogenesis in offspring, likely through epigenetic changes transmitted via the paternal germline. Behaviorally, this is a classic case of supplement overuse. People take high doses for anti-aging, fertility boosting, or detox, often combining multiple antioxidants without blood monitoring. Over months or years, that chronic overload can quietly interfere with reproductive biology. Real example: a man takes 2,000 mg vitamin C, 800 IU vitamin E, and high-dose NAC daily, to improve sperm quality. Instead of protection, the excess may reduce physiological ROS needed for sperm capacitation and embryo signaling. The study suggests we should be cautious with megadosing, especially men planning to conceive, because paternal exposures can influence offspring beyond just genetics. When it comes to scientific theories, clinical data, and terminology, The Texas A&M VMBS study in early 2025 used a murine model with chronic high-dose administration of a cocktail of antioxidants, specific compounds and doses detailed in the paper, exceeding typical human supplemental ranges. Key findings: increased sperm DNA damage, measured by COMET assay and 8-OHDG levels, altered global DNA methylation in spermatozoa, and statistically significant changes in craniofacial morphometrics in F1 offspring, landmark-based geometric morphometry showing shifts in facial shape indices. This research supports the idea that a little stress can be good, but too much interference can backfire. Small amounts of reactive oxygen species, ROS, the molecules your body produces during stress, can actually help your cells adapt and become stronger. But if you take too many antioxidants and suppress ROS too much, it can cause a different kind of problem called reductive stress. That throws off your cell's balance, messes with energy production in mitochondria, and even affects how genes are regulated. This matters especially for sperm. Scientists are finding that a father's lifestyle and stress levels can influence how his genes are packaged, through changes in DNA methylation and histone modifications. These changes don't cause birth defects, but they can subtly shape how a child develops. It's a new frontier in understanding how health and aging can be passed down. Not just through genes, but through how those genes are regulated. Human relevance remains extrapolative. Mice metabolize antioxidants differently, and the doses were supraphysiological, but the principle is biologically plausible and echoes prior work. High-dose vitamin E or C combos in some human trials showed no benefit or subtle adverse effects on sperm parameters. No large human RCTs yet directly replicate craniofacial findings, but sperm DNA integrity is linked to miscarriage risk and developmental outcomes in clinical fertility studies. Practical advice: get antioxidants primarily from whole foods, berries, leafy greens, nuts, seeds, colorful vegetables. If supplementing, stick to moderate, evidence-based doses, e.g., 100 to 400 IU vitamin E, 500 to 1000 mg vitamin C, unless treating a diagnosed deficiency under medical supervision. Men trying to conceive should be especially cautious with high-dose regimens and consider basic semen analysis if concerned. In summary, antioxidants are protective at physiological levels, but excessive supplemental intake can backfire, potentially harming sperm DNA and subtly influencing offspring development. Balance beats overload every time. Thanks for watching. I'm Dr. X. If you're taking high-dose antioxidants, share your reasons in the comments or talk to your doctor. Stay balanced, stay informed, and I'll see you next time.